about the amount of new data that Nuria and her team have collected and been working with, it is yet another reminder of how data sets are growing exponentially. And with that, of course, comes a challenge of how we integrate data and what parameters we set for data. And how do we organize, collate, and indeed define data sets with a view of making them useful for real-world applications? Well, to help answer these questions, we're going to be joined by Professor Petros Koumoutsakos, who's joining us live from Harvard in the USA, and his industry panel, drawn from Mitsubishi, Splunk, and Jaguar Land Rover. So, Petros, over to you.
I'm very happy to be here, and I'm very happy to have this conversation today with Dawn and Muhsin. So the topic is integration of data in the industry, and perhaps we can start by me asking Dawn first to give us an example from Splunk, how Splunk goes about integrating data into the projects that they have. And then we can follow with Muhsin and then carry on the dialogue from there. Dawn, please.
Thank you so much, Petros. Very excited to be part of the panel this morning. Your question about how is industry integrating data to develop and an example of how we're developing applications. I think that, Splunk was founded on the premise that enterprises need to be data-driven. So how do we make sense of this ever-increasing volume, velocity, and especially the variety of data that's going to be coming in? So integration is absolutely paramount for Splunk and for our customers. So what we strive to do is enable the integration of data from any source, from anything that's digitized, and unify it to provide a full picture of the enterprise. And it's important so that you could improve the accessibility, make the data usable, and gain business insights, as well as collaborate and share across the various teams in your organization. So by having that unification and integration of data, you have the ability, and Splunk helps provide the ability to investigate, monitor, and analyze and act upon your data. So for those of you who don't know what Splunk is a platform focused on data integration. Our customers and our employees, ourselves, we use Splunk to ask these questions of our data. And the data, again, it may be structured or unstructured. It could come from a variety of sources. It may be streaming or real-time, or we may want to look at historical data. The data could be, and the questions that we ask could potentially be on repeat, where you want to routinely look for anomalies or look for issues. And it has to be able to scale on demand, because you never know exactly how much data you're going to get, given that you may have real-time operations or other activities going on. So ultimately, you need some sort of data platform in order to turn your data into doing. So I could talk a little bit about, since you asked for an example, I could talk a little bit about how Splunk ourselves have done this, and then maybe later on in the conversation, I could provide some other examples of how our customers and partners are doing this as well. Would that make sense, Petros?
Makes absolutely sense. Let's go first to get some words from Muhsin, and then we can come back to that.
All right, sounds great.
Muhsin, please.
Yeah, so
some comments on the integration. Yeah,
absolutely.
And what does it mean? For you.
For my side, being at Mitsubishi Electric Research Lab, we work a lot with Mitsubishi, and so my side is more like mechatronics and the physical systems, mechatronic systems or power systems, and the data comes from sensors that are put in the system. The data are collected during the operation of the system over years, and we try to use that data to monitor aging of the systems. So it's a bit similar to what Stone was talking, especially on the anomaly detection, but for the aging of a physical system, let's say. So, and the data is collected over time, not So the number of sensors will be the same, but the data grows over time rather than over the number of sensors. And we use it to monitor the health of the system and then eventually the safety of the system when we are integrating the data in the modeling and the control of the system. So the application are several. We have like a speech application, natural languages. So we work on that. We have computer vision for robotics. And then we have more low-level, let's say, systems as brakes, electromagnetic brakes that we use for high-speed elevators. So they're very safety-critical systems. We apply, of course, like every other company on mechatronics, we work on autonomy for trains and cars. And we also work on power systems. So power systems can also be improved using some this kind of data-driven approach, which is really a new paradigm now in the power system community, where sensors are being used and, let's say, power amplifiers are being retuned on the fly based on the frequency of the signals or temperature around them and such things. So that's from our side, the application that we have.
Yeah, thank you. So I noticed that Dawn used two V words to describe the data. One was volume and the other one was variety. And I think these two words also echoed in what Muhsin said. So there is another V word that I am particularly concerned, and that is the veracity of the data. So I would be interested to have some comments from both of you. Maybe we can start with Muhsin this time to tell us how do you go about the uncertainties that are inherent in the data? How do you go about outliers? How do you go about knowing that the data you get are data that you should be using?
Absolutely. So this is a very important problem for us and for data-driven, I suppose, for using machine learning, especially if you're using them for systems that are on the fly and again, safety critical, like a car moving around. So the uncertainty is a very big problem now, and we try to compensate for uncertainty using knowledge that we have before for centuries from physics, let's say. So we have models of things. Again, this is, Dawn will comment on her experience, but from my side, because we work on mechatronic systems, we are lucky, so to speak, that we have centuries of physics around the systems and models that we cannot throw away. So what we decided to do is this hybrid setting where we use the physics as much as we can, and the data-driven is to complement the physics. By this interplay between the model that we trust as much as we can, and the data also that we trust as much as we can, both of them can help each other to take care of uncertainties. Without going into the details, but we use robustness from the models for robust theory. This is some mathematical theory that allow you to compensate for any uncertainty coming from the data. Mm-hmm. By getting knowledge from the physics, from the model. And this interplay helps us to compensate for uncertainties in the data. I don't know if it was responding,
Yeah, that's very, very interesting. So I guess, Dawn, for you, the case of physics is not something that exists in the enterprises that you're dealing with, but maybe you can tell us, maybe by an example, how do you guys consider the different data? How do you check them for their uncertainties, for their truthfulness? How do you go about outliers, perhaps? Please.
Yeah, no, I think that what Splunk is a data platform. So we have the ability to accept data in whatever structured or unstructured format that it comes in. And we have the ability to do both real-time analysis as well as historical analysis of the data in the Splunk platform. So I think that, to get at your question, how do you know about, the veracity of the data? I think one of the things that we do is we look at historical data to understand what is the normal baseline, what should we normally expect. And we could do anything from simple thresholding analysis, or also provide the ability for real-time monitoring through dashboards and visuals, so that if this is something that your security operations center or other network monitoring center wants to look at real time, we have the ability to provide that, as well as various algorithms for anomaly detection, and see if there's something that is unusual, and then alert or draw the attention of the user or administrator to understand, if something unusual is happening.
Yeah. So I know. So we had a discussion at the preparation for this talk, for this discussion. So Dawn, you brought up an example from Gatwick Airport. So maybe we can go a little bit more into a concrete example of how do you guys help Gatwick Airport. As I understand, this is a place with 46 million passengers a year, some huge numbers associated with that. Maybe you can tell us, how do you guys concretely go about addressing data in this in this problem? Yeah,
sure. Thanks, Petros. So I'm sure all of you in the UK are familiar with Gatwick Airport, and many of us who have come to visit also are. Gatwick is a very busy airport, as Petros mentioned, with 46 million passengers per year and 55 air traffic movements an hour, all done on a single runway. So imagine how busy that must be. So the challenge that Gatwick had is to make sense of huge amounts of data from uncorrelated systems and disparate sources. So what they really wanted to do, and what Splunk helped provide, was to provide a full real-time view of airport operations. Because what they, as well as most enterprises, want to do is they want to bring data to help make their decisions. And so you can imagine, with an airport this busy, with this much throughput and this much air traffic, that efficiency is one of the most critical aspects in order to operate successfully. So as an example, they need to have full transparency into the security lane performance, the operations on the airfield, as well as for baggage systems and control. So it's very critical to have a unified real-time data platform that enables all of the high throughput volume that is needed. And by bringing all of these data together and consolidating it into a single platform, it's enhanced the contingency and resilience of the airport operations. And so some of the output of this is that they're able to get 95% of passengers through the security checkpoint in less than 5 minutes, which, for those, once we're all traveling again, we'll very much appreciate that. And it also enables the airport not just to get passengers through security quickly, but also create alternative views into the flight information for passengers as well as airport staff, even when routine contact is lost with some information systems, by having this integrated view of all the data systems within the airport.
And Muhashim, in some of the notes you sent me before the event, you had maybe not security, airport security, but you had also another important issue, which was safety in some of the important devices that Mitsubishi is concerned: electromagnetic brakes, HVAC systems. Maybe you have a particular example to tell us. How do you guys go about that? How do you incorporate the data in solving a particular challenge from your experiences?
Yeah, I mean, to just comment a little bit on the airport example, which is really fascinating. There is also work we're doing here about seamless checking, so using image processing and data to recognize people and let them pass. So I think that's very interesting in the platform that you mentioned. For what I am involved in, some of the examples I sent you, one of them was HVAC systems, so air conditioning systems in buildings. And we're trying to use sensing, like thermometers, or also velocity sensors, like airflow velocity sensors inside of rooms, to refine models that we have about how comfort is felt inside of a room. So instead of I'm sitting here, instead of having air conditioning blasting and trying to regulate the whole temperature in the whole room, we can focus on an area around the person in the room and try to make that area close to the comfort set point of the person. And we can learn from the person choices over time. And then we can also recognize the person in the room and switch to let's say, the air conditioning tailored to that person. So doing that, using a lot of data-driven, so like reinforcement learning to learn the behavior of the person, what is comfortable for this person, and then using also data-driven for the airflow modeling, because it's a huge model. It's require like PDEs, partial differential equation, which are notoriously complex to solve in real time. But because we are mixing some simplified version of this equation and the data, again, the data over time, we can simplify and have a more precise model of the airflow inside of a room together with the person, and overall have a better comfort and also minimize energy consumption in the building. So that's, I think, one of the recent examples that I wanted to talk about using like machine learning and data-driven.
So in your processes, I understand that you're both using data, you rely on data. This conference actually has the title, this workshop has the title Data-Centric Engineering. So one question is, if the data is at the center, where are the humans? Do we get rid of them? Would this discussion be one day be carried out by some machines that have handled the data, and we will not be necessary to be even here? How do you see the human in the loop? Does it figure anywhere? Is it important? How do you see it in the problems that you are solving? Maybe we can go back to Don now.
So, Petros, I don't think that human will ever be out of the loop when it comes to making the important decisions. I think what we want is the data platforms and the systems to be data-centric and help inform the decision. But I think of these platform systems more as a decision support tool as opposed to the decision-making tool. So, understanding and getting alerted in terms of what you need to pay attention to, because you see there's anomaly detection, or you see strange behaviors in the data that are unusual, and, recognizing unusual patterns, or like if you think about an enterprise system where you have, like we all do now, have multiple remote workers connecting at the same time, you'll begin to understand what the normal patterns are. But when you see something very unusual, like a large number of people connecting from an unusual location, that's when you need to bring the human in and say, hey, pay attention to this. But ultimately, it's up to the humans to make the decisions, and the data is there to help support it.
And how does it work in your field, in your industry, Mohashin?
I think it's the same. So if you like earlier I mentioned image processing or computer vision applications, and we do have applications like helping, for instance, in medical field, in radiology. So there's this long discussion about, would we need radiologists in the next 10 years at all, or would they be removed, just using software to detect, to help physicians read the scans. And I think it's the same what Don said. I don't see that the humans knowledge will be removed, totally removed anytime soon, thank God. But all those softwares come as a help, as a support to the humans and to specialists in any field. Maybe have them gain time, so zoom in on the real problem or the anomaly, and let the human make the final decision. For instance, we do a lot of work in autonomy, like autonomous cars. I do not believe that full autonomous cars will be deployed anytime soon. You will always need supervision, at least, of a human for critical cases. So maybe the only way where this might happen is if we switch to a completely robotic society. So everything is automated, and let's say for the case of autonomous car, if the cities themselves become like sensors, like you have sensors everywhere, so you have to change the whole mindset. And the humans will be just guests in this robotic society. Maybe in that sense, we can remove the humans in the loop. But in the normal progress of things, I see more of all these algorithms, all these data-driven algorithms, as a support to humans, to specialists or to users.
Yeah. So another more personal question coming here from the perspective of an academic. So as we are preparing people to go out to the world, we educate the next generation of people. If you had a wish towards academia about what should we be teaching the students for them to be let's say, for them to be useful for your enterprises, for them to be integrated in a successful way in tomorrow's workforce. What do you want us to teach them? Do you want us to teach them more machine learning, more mathematics, more thinking, more philosophy, more history? If you had a wish list, what would you be asking academia to be teaching the next generation? In which order?
So, Adil, should I start or Dan? You want to start?
Yeah, Mohsin. Let's start with you, Mohsin.
Okay. So quickly, I mean, in my sense, yeah, machine learning should be definitely covered now because it's important. But what the mistake where we receive a lot of student interns from academia, and I think the lack that I'm seeing now is more in the fundamentals of mathematics. Because machine learning has been introduced a lot, and without spending time on the fundamentals of machine learning. And I think in academia, we should be careful not to remove that part, the fundamentals about where things come from, especially if the students want to change the algorithms and go deeper than just black box usage. And then where we start talking about uncertainty and safety and ethical machine learning for some applications. For these, we need a fundamental change in the algorithms, and the student need to have the right background in mathematics, statistics, and the underlying theory to improve, I think, this machine learning algorithm that will need improvement with all the challenges that we mentioned in this discussion.
And Dawn, would you have some words for us?
Yeah. No, so I think I agree a lot with Mohsin, right? The fundamentals are absolutely important in math, statistics, machine learning, and programming. These are all very important. But I think one of the great things that universities have and institutions like Turing have is the ability to bring together folks from many different fields and have that kind of integrated view into the context for the problems that they're going to be solving with this fundamental knowledge. So the more that you know about how real world applications or what real world problems are, that will help provide the context for all of that foundational learning. So yes, focusing on the fundamentals, but also bringing in the applications through institutes like the Turing, where you have academia, industry, and government and others all come together.
Okay, thank you very much. I would like to close this session. It was fantastic, very exciting to talk to both of you. I want to thank you for taking the time, and I want to thank also the Alan Turing Institute for putting this program together and for hosting us. Have a great day, everybody.
Thank you, guys.